All right, let's do the second problem set, which is about utility maximization. And we have a utility function which is equal to the, as we told, utility is 20 times the log of x. So this time we have a function with the log. And this behaves very similar to a function that involves the square root. So, and I have already showed you earlier, the most important thing is then when we derive it, that the change in the log of x with respect to dx, that is simply 1x. That's the first derivative. But anyhow, before we go into the slope, let's just draw it quickly. So if we have here x, and here we have 1, the log of something which is less than 1 is always negative, so it actually turns out to look something like this. And then we have an expenditure function, so this is the total utility. So notice this is the total utility, not the marginal utility, and we have your total expenditures. And the total expenditures look something like a straight line, so E equals 4 times x, and the total utility is 20 times ln of x. Okay, so, and I will do that also in Excel, but the first question is, what is the net utility function, which is defined as the total utility minus expenditures. Okay, so let's do that. So the net utility is now simply the total utility, which is 20 times the log of x minus 4 times x. Okay, so now draw the net utility function into Excel for the domain from 0 to 10 with a step value of 0.1. Okay, so let's do that. And let me quickly see if I can pull up here an Excel sheet. And maybe I can squeeze it in here. Okay, so first step we do is we create, again, dx. Maybe I can zoom in a little bit. So we always start with the x-axis, and that is supposed to go from 0 to 10 with a step value of 0.1. So what I do is I actually quickly activate my keystroke. So let's quickly key. Okay. Okay, so it should be on. So let's go back to, okay. Okay, turn on. So now we should be able to see the keystroke. Okay, good. So first thing I do is I highlight the column, and what I do is I press now with my left thumb and index finger, Control Shift, and I have a real keyboard, so, and then arrow down. Okay, and then I'll go to Home, and then there is something called Fill Series. So we have to go to probably Editing, Fill Series, step value 0.1, step value 10. Okay, so the next thing is the net utility. We said the net utility function is, so you still see it here, 20 times ln of x. And actually now we will get an error message because you cannot take the log of 0. or you cannot take the log of something negative, minus 4 times x. So that is the net utility function. The net utility, the total utility minus what you have to pay for it, or the cost that you incur. Okay, so now let's copy down that formula. And again, for the first, I just replace the number that is not defined by number non-available, so then Excel will just ignore it. Okay, so this is now our net utility function that we try to maximize. So let's see how that function looks like. Okay, let's take this one. So it looks a little bit similar to the way I drew it. Maybe we can do the axis a little bit nicer. And I'll just do the tick marks at 10 and the labels also only at every 10th unit. Okay. So now if you look carefully, we can see that the net utility is maximized probably at the value of 5. It seems to be plausible. So here it looks like as if we have a maximum. Well, why is that a maximum? Because at this point the slope of the net utility function is 0. So that's why we always use the condition that the first derivative, the slope, where that is 0, we have a maximum or a minimum, could be a minimum too. But just from a graphical inspection, we can see that we probably have a maximum at a value of 5. Okay, so 5 seems to be the optimum level of consumption. Okay, so we draw the net utility function. So now derive the utility maximizing level of consumption graphically. We just did that and we just saw, okay, that optimum level, which is x star, is probably at 5. But what is the first derivative of the net utility function? And so the net utility function, I'll just draw that, or I just sketch it again quickly here. X, and then here we have the net utility. Net utility, and we got a function which looked something like this, and we saw that at 5 there is some kind of a maximum because here the slope is 0. Okay, so let's take the derivative of the net utility function, and that is d nu with respect to x. Okay, so the log of x, taking the derivative is 1 over x, so we are just left with 20 times 1 over x minus 4. And now we find the point where this slope has to be equal to 0. But this is the derivative. Okay, so this is the derivative. So now in E, what we are supposed to do, set the marginal utility function, which gives us the point, the slope at every point equal to 0, and let's solve for the optimum. Okay, so we get 20 over x minus 4 equals 0, and now we solve for x. How can we do that? Well, maybe first we add 4 on both sides, and then we can write 20 over x equals 4. And then if you want to solve for x, we just cross multiply and divide by 4, and then we get x star is indeed 20 over 4, which is equal to 5. So now we get the same result mathematically. Okay, how big is the net utility? Okay, well, we can look that up again at our Excel sheet. So we just go to the optimum level, search for 5, and here it is. So the net utility is around 12.189 or so. 12.19, that's good enough. Okay, so the net utility in the optimum is 12.188, so let's say 19. Okay, so that was the first example. I'll just stop here and then we do another one in the next video. Okay, I hope to see you there.